Welcome to the ET302 how-to video for the operational amplifier lab. We're going to build it in Multisim. Okay, here we are at Multisim. Let's go ahead and build our op-amp lab. And I'm going to build both types here. So first thing we're going to need to do is get some voltages. So let's go to sources. And we're going to get a VCC. And we're going to get a VEE because it's minus. And we're going to need, let's go ahead and just get a, we'll just make it a VDD. We're going to need a very small voltage. We might as well use one of our built-ins. And we're going to need 2 resistors, so let's go to basic. Resistor, so let's just get 2 1Ks. We're going to change these anyway. Good, so let's go ahead and get a op-amp. So we're going to go to op-amp, so let's just get a 741. Let's get a real one. Let's see what happens here. Yeah, that'll work here. Okay, now we need to fix a few things here. We need 4 on top because we usually, this is opposite of the way that we usually build these circuits. So let's go ahead and flip vertically. Good, so we have the 4 on top and the 7 on the bottom, which is a positive, and we have the inverting input on the top and non-inverting on the bottom. So let's zoom in and build it. Zoom area. Okay, so VCC we're going to put on the bottom, so we're going to flip him vertically and we're going to change him to 12. Oops. Okay, that's better. And we could just go ahead and move our 12 back down where it belongs. Good. So now let's take our VEE. Let's go ahead and see if we can grab it. Yes, and we're going to convert him to minus 12. These op-amps work on a plus-minus power system. So let's go ahead and we're going to make this guy, we're going to make him RF for feedback. Yeah, let's just go ahead and put feedback. Okay. And this guy is going to be our input, so we're going to call him RN. Okay, and he is going to go into our inverting input, the one with a minus. And this guy, feedback resistor, is going to go to our output and in front of our input resistor. Alrighty, so VDD, we're going to put that on top, and that's going to be our input, and then we're going to start off with 100 millivolts. So let's go ahead and change this to 100 millivolts. Little M. Good. And that is a positive, and we need a ground. And eventually we're going to need probably a voltmeter or a DMM or a oscilloscope. So this one looks done. I'm going to give you this file, but let's go call it we're going to call it op amp DC1. We're going to call it invert, INV DC. Alrighty, so let's go ahead and let's take off this guy, and we're going to use an AC signal. So let's go back to sources, input sources, and we're going to say AC voltage. That should be okay. And we're going to put the positive in. Let's go ahead and borrow a ground. And now we have an AC input, a sine wave. So let's go ahead and change this to 100 millivolts. Oops, we don't need the B. All right, 100 millivolts peak. And it doesn't say, but we'll go ahead and leave it just like that. 111 K zones. Looks like we got two of our signals mixed up here. Okay. We're going to call that op amp inverting AC. Okay. So let's go ahead and save as. We're going to call it non-inverting AC. Since we already have it here, we'll go ahead and start with this one. So now what happens is when we have a non-inverting, our voltage is going to go into our non-inverting. So let's move that up there. Let's move this all down. And now we're going to have our AC input into our non-inverting input. And now we're going to ground our input resistor. And everything else remains the same. So let's go ahead and save this one as just what it was. Yeah, it's good. We're just going to save it. Okay, now let's save it as we're going to make it a DC now. Alright, let's get rid of our AC clock. And we don't need a ground for this one because I'm going to go ahead and use VDD again. So let's go to sources, signal sources. Actually, go to power source because it's DC, and we'll make it VDD again. And we could rotate that 90. And we could run it right into our non-inverting, and let's change this to 100 millivolts. Good, and we are done. Let's make sure it's saved.